Okay, welcome everybody to my talk about LibrePCB. My name is Urban Bruhin. I'm from Switzerland, and yeah. So first, what's LibrePCB? It's actually similar to Horizon, an EDA tool, a new open source EDA tool. It's multi-platform, so it works on Linux, Windows, and Mac OS. And it's written from scratch in C++ and Qt. And I started the development in about five years ago. So yeah, and the code is on GitHub, so you can check it out. And first, the reason why I created a new EDA tool, basically also the frustration about existing tools. 5 years before now, think about how KiCad was then and so on, and it was I was really frustrated about the existing tools. And the main reason is basically the library system, which is very limited in other tools. And also the file format, especially when using version control systems. Other EDA tools, they have a file format. If it's maybe it's binary, then yeah, good luck. But if you have luck, then it's text-based, but still not very good suited for version control. And also the usability is often not very great of the tool. So something about the library management. One thing is other tools have different library file formats for different kind of library types. So for example, one library type for components, one for footprints, and so on. And I think this is not really nice for users, because maybe the tool sometime adds support for SPICE models or something like that. It also introduces a new file format for libraries. And yeah. And the other thing is tools do not really completely handle library management. So there is often no integrated tool to install and update libraries. If libraries have dependencies, so the tool does not handle this. So you as a user need to handle dependency management. And the project library management is also a little bit complicated sometimes. So the result is actually the user has a lot of work to handle or to manage his libraries he wants to use, and that's quite a pain. So, for example, as an Eagle user, you maybe know this website where you search for libraries, download something, and install it manually. Or in KiCad, in the schematic editor, this is the library configuration dialog. Or in the board editor, I see a lot of file paths there and some environment variables and path substitutions and project-specific libraries, global libraries, and so on. And I asked myself, why is this so complicated? I just want to use these libraries. So my answer is it doesn't have to be that complicated. So in LibrePCB, I integrated the library manager to update and install libraries. And it also has a simple library dependency management system. So if you download a library, library A, which depends on library B is automatically installed when you install library A. And probably the most important thing is the application basically handles everything for you. So you don't have to care about libraries. They just work. So because there is no reason to make this very complicated. And another thing is actually similar to the Horizon tool. The problem of other tools is they reference many things just by name. And in some tools, it's even not possible to reference library elements across libraries. So you can't use a component from library A with a symbol from library B and so on. And the result is there are often broken references when changing names or name conflicts and many duplicates because they cannot be shared between libraries. And the solution is actually the same as in Horizon. We use UUIDs for every kind of every entity in the library. So every symbol, every pin, every pad, everything has a UUID which never changes. So you can change the names and so on, and it doesn't have any effect. It doesn't break anything. So. And it's also possible to reference libraries across reference entities across different libraries. For example, if you take a look at the file format of LibrePCB, which is based on S expressions, you can see that there are many UUIDs there. For example, a symbol looks like that. At the top is the UUID of the symbol itself, and the name is just a property which you can change anytime, and the same for every pin. So another problem of existing library systems is there is no way to have different symbols for the same component. So, for example, a resistor can have an American or a European symbol, but there is no solution for that in many tools. And this results in duplicated components with exactly same functionality but different symbol. For example, in Eagle, it looks like this. So if you have a resistor component and its resistor symbol, and the resistor has, for example, 3 devices, it looks like that. And if you want to have an American resistor symbol, you have to create an American resistor component. And you can't use the device from the European resistor, so you have to copy them. And maybe there is even another variant of the symbol, and you have many duplicates of devices. And this is quite a mess, so the quality of library gets worse and worse. Yeah. So the solution of LibrePCBs, there is an entity called component symbol variant. So there is only one component for a resistor, and it can have as many representation variants as you like. So you can create one for the European symbol, one for the American, or whatever you want. A similar problem is with packages or footprints, because libraries do not have an abstraction layer for packages. For example, this TO220 package, this is 3 times the same package, but 3 different footprints. And this is quite common. For example, you have different footprints for different mounting variants or different size of pads, because one for reflow soldering, one for hand soldering, and so on. But libraries do not provide a way to abstract this. And so the result is every device needs to know every footprint variant of their package. For example, if you have a voltage regulator in a TO220 package, there's one relation between them. If you have one more device using that footprint, you have one more relation. But if you have some different footprint for the same device, for example, this time without the mounting hole, you have many-to-many relations. And let's add one more device and more footprints. And you can see you have a many-to-many relation between devices and footprint. And that's quite a nightmare in a library system. So LibrePCB adds an entity called package, which doesn't know anything about footprints directly, but only what paths it has. And a device references only a package, and the package can contain as many footprint variants as you like. So the next problem is version control systems. It's quite hard to version control EDA files because often important and unimportant data is mixed. So you cannot just check in the important data, but not the unimportant. And it's often even unclear which files to put under version control and which not. And the typical results is you have local changes even if you didn't modify anything in a project, or very large diffs, and merging is for sure impossible. And LibrePCB solves this by using many smaller files instead of one single big file. So it's you have higher granularity, and you can easily distinguish between imported and unimportant data. And one very simple improvement is the tool automatically creates a git ignore file, so the user doesn't need to know which files to check in or not. And another thing is, this is a diff of a KiCad PCB file. I just created the PCB, opened the editor, zoomed around, toggled some layers on and off, saved the project, and looked at the diff. And this is the diff. And you can see there are changes which actually you don't want to check in these because they are only irrelevant data. And at the bottom, there is actually, the diff is 1 bit of some number. I don't know the exact reason of it. And this brings me to the next point. Files are not really human readable. So diffs are hard to understand, and version control system are hard to use on these files. So my solution is basically, first, don't just consider text-based file formats as human readable. Not every text-based file format is human readable. You need to control every tiny detail of the file format to make it as readable as possible. And in LibrePCB, I consider parts of files which are not really human readable as bugs, and bugs need to be fixed. So the current project status is actually the library management works pretty good. The library editor has only basic features. It works kind of, but not very good. And the schematic editor is also working pretty good, except some important features like copy and paste. And the board editor is at the moment work in progress. So there are no plane sets, no air wires, no designer rule check, and so on. But Gerber export is possible, basically. And of course, the available libraries are, there aren't many libraries available. And the most important thing is the file format is not yet considered as stable. So you can use LibrePCB already for some simple PCBs. But don't expect that you can open the files, for example, in a year with the newer version. So to get started, there are nightly builds available at the moment for Linux and Windows, and also some documentation. Okay, now let's show a short demo. This is actually just the app image I started, directly downloaded from the internet. This is only the first time it says to create a workspace. Then the project, the control panel says you need to install some libraries. So you open the library manager, and these are the libraries available in the internet. And for example, I want to install this library. It also selects the library here because they are dependencies. So, and if I unselect this, this is also gone. So let's install these libraries. They are downloaded from the internet. And here we have some whatever some libraries. Okay, so now let's create a new project. Then the schematic editor is here. And as an example, I just add some components so you can see how the workflow would be. For example, capacitors are now available in the European symbol or the American symbol, so you can just add the American variant. Or you can also choose only a component or an exact device. It doesn't matter. So this one is just an N-channel MOSFET without choosing already a footprint. So maybe ground, VCC, make some connections. Whatever, doesn't make sense, but so, okay. Now in the board editor, we can see there are 3 parts which are missing on the board right now. So we can choose, for example, the resistor, choose the exact device, add it, and the other devices. And for example, the MOSFET, we have 2 devices available at the moment. And for the TO220 device, we can also choose between the different mounting variants. So let's add this one. And one cool feature is also you can copy a board. Then you have 2 times the same board and can work independently on them. So you can, for example, in this board, you want to use the other device. You can just switch to the other one, or you can also choose just the other mounting variant. And also the board and the schematic is also in sync. It's always in sync. So, for example, if I remove one resistor, it disappears from both boards in the time. Yeah, it's like an eagle basically. And yeah, you can. Okay, that's.
So in Eagle, you can't actually do that. You can only delete from schematic, not from board.
Sorry?
In Eagle, you cannot delete from the board. You can only delete.
Oh, okay. It's right now. It's also not possible in LibrePCB to delete from the board, but it's planned to do that. So if I delete something, it appears in this list because it's not added to this board. But here it's still available in the other board. So okay, and after, let's say you have, okay, that's just because I said already the board editor is in work in progress, so there are some strange things. And there is even a very simple Gerber exporter without any option, but you just click generate and open the directory, and if you don't trust me, the files are generated in this. So, yeah. So you can just open them with GerView, for example. And here it is. So very simple, but it works. Okay, so I think this is, yeah. So now the next steps. The first, the highest priority at the moment is to stabilize the file format, so do the last breaking changes and to create the first stable release. And for that, I also need to make the board editor really usable because it doesn't make fun like that. But it's already possible to order PCBs. So, and yeah. The next step is add more functionality, but yeah. So contributors welcome, of course. And yeah, that's it.
Questions for Urban? What's it written in?
The language,
yeah.
C++ 11 and Qt 5.
Sorry, I hate to be redundant.
Why not just participate?
Okay, the question was again, why not instead contributing to KiCad? And actually my answer is similar to the Horizon one, because I think the library system is that important part of a EDA tool, and it's a very fundamental low-level part, and it's very hard to change this concept. And I think in LibrePCB the concept is completely different than in KiCad. So
I think you see Wayne going like this.
This is a project manager. I just do that.
And
I'll entertain any good idea, but remember it has to meet the criteria for library manager that KiCad has to do, and that is we have to be portable across platform. So, and that means if I pick up a project from this computer and I have another computer of a completely different one set up right, it should be the same. I should get the exact same result on that computer. And that's one of the keys for KiCad. And
okay, but
I think it's subject for discussion later.
yeah.
More questions?
Have you considered taking into account bill of materials? Because when you design schematics and PCB, but then when it comes into actually producing the devices and boards, you can have many variants of each component. And so it's not really the design of the board, but in terms of manufacturing, it's often something that needs to be kept under control. And that's a nice feature I've never seen in CAD.
So,
where do you get the explosives from? Where do you source all the different bits?
so
You can say I want a BC547, but then many different.
So your question is the generic devices, where to order them then? Or?
Like order codes from different vendors.
Yeah.
This is something he didn't solve, right?
Yeah.
So if you can source it from DDK or Mauser or other supplier to add this in the libraries.
So yeah, so the question is the part numbers, are they part order codes and exact part numbers and so on?
They be included in the library.
If they are included in the library, and the current answer is at the moment it's not part of the library, but I already have plans how to integrate it, so it will be in the library later. So yeah.
The goal should be like the design of the build change, but every time you do this bit of the board, you might have to change the supplies, and if something behaves differently, you can track the change between like one version of the board and the next one. So having it part of the library might not be ideal, but at least having really different versions of version control and supplies.
Yeah.
Does any of the program have multiple views, so I can follow, for example, I have the fallout of the PGA and I want to go to the other direction, and then keeping the overview is quite hard if you only have one view.
Sorry, where is only one?
Multiple views, that you see perhaps the whole layout where you are in, where you want to start and where you want to end, and you see you have another window where you are at a much larger scale.
I'm not sure. You're asking about the board editor, or?
Is it intended, for example? Does it have? Can you have multiple views?
Okay. Is it intended to have multiple views of the same board, basically, with other regions? Yeah. It's not planned this time, but of course it would be useful. Yeah. Yeah.
Okay, we don't have time for more. Let's thank Urban again.
Okay. Thanks.